Sounds good. Well, I'm Jim Vajda. I'm the Chief Wireless Officer here at 7Signal. I'm CWNE and various other things on this slide. And today we're talking about Wi-Fi 6E and the use cases for healthcare, which are, of course, top of mind for the attendees here at HIMSS. So a little background on Wi-Fi 6E. So this is a branding or marketing term that comes from the Wi-Fi Alliance. And what it is talking about is using that 802.11ax protocol, which is also branded Wi-Fi 6, in this new 6 gigahertz band that we can use for Wi-Fi now. So Wi-Fi 6 was the same protocol in 2.4 and 5 gigahertz that we've had for so many years. But now Wi-Fi 6E is taking the same protocol and extending it into that 6 gigahertz band, which here in the US, the FCC granted or opened up for unlicensed access, including Wi-Fi, of course, back in 2020. And we've seen a big increase in regulatory bodies around the world also opening up some or all of the 6 gigahertz bands. And by now we have APs from all the major enterprise AP vendors with Wi-Fi 6E support released. And many clients are available now too, and we'll talk about some of those. But the big deal, the reason this is such a big deal and one of the biggest improvements in Wi-Fi in a generation is because of the increase in available spectrum. So you can see on that chart on the right, Wi-Fi started with that 2.4 gigahertz band to use, and it has about 80 megahertz spectrum. And then later we got access to the 5 gigahertz band, which is about 500 megahertz of spectrum we can use here in the US. And that's really the reason why Wi-Fi performs so much better in 5 gigahertz. More spectrum means more capacity. It means there are fewer clients and APs on every channel that's in use. And then that means, with fewer radios on each channel, they get channel access more often, which means better throughput, lower latency, and so on. Not only that, the spectrum Wi-Fi uses, it's not Wi-Fi spectrum, it's unlicensed spectrum. So anybody can use it. It could be, it doesn't have to be Wi-Fi that is using these channels. It could be Zigbee, could be Bluetooth, could be Thread, could be some weird analog, transmission. There's a lot of other transmitters using these bands. And 2.4 gigahertz has the smallest available spectrum, but the most competing protocols operating in that band. So it's noisy, there's a lot of interference, it's congested, and 5 gigahertz for a long time has been the answer to better performance for Wi-Fi, regardless of the generation, whether it's 802.11n or AC or AX. The real performance increase comes from using that larger spectrum in 5 gigahertz with less interference. So you probably, from explaining that, you probably can see how big a deal 6 gigahertz is, because this is now more than double the amount of spectrum that we had before. And actually, if you think about the total amount of spectrum, including all the bands, now we have triple the amount of spectrum. So that unlocks a lot of things for Wi-Fi. I think it's more important than 802.11ax itself, actually. And we'll talk about how that's relevant for healthcare, as we go. So a closer look at the 6 gigahertz spectrum. We have 1,200 megahertz of new unlicensed spectrum here in the US. That gives us 59 new 20 megahertz wide channels. That's amazing. In 2.4 gigahertz, we really just have 3 non-overlapping 20 megahertz wide channels, and now we go up to 59, which means we can use wider channel widths without having co-channel interference. It really unlocks a lot for us. And another big benefit of it is for the current class of devices, the low power indoors APs and clients that support that fall under those rules. We don't have to worry about DFS rules like we had in the 5 gigahertz band. So if you look at the middle chart there that shows the 5 gigahertz channels, all those blue and the yellow channels that are in the middle, that represents 2/3 of the channels in 5 gigahertz. They're all subject to these DFS rules, which means if there's a weather radar, if there's a military aircraft, if there's another incumbent that shows up and starts using that channel, the AP and clients have to move away from that channel and can't come back for another half hour. And they have to be very sensitive to that. And unfortunately, we deal with false positive DFS events a lot in 5 gigahertz, even today with the latest gear. It's really a problem. And that's a problem for 2/3 of the band. With low power indoors in the 6 gigahertz band, we don't have any of that issue. We're free to use those channels and not worry about interfering with incumbents and staying out of their way. The way we protect incumbents under LPI is we make sure all our transmitters are inside, indoors, and the power is below a certain threshold, and that's enough to keep them safe from us. So huge benefits there. So, if we kind of take stock of some of the major Wi-Fi challenges in healthcare, some of the things that are on my radar, and I did manage an enterprise Wi-Fi network in a hospital system for a while. Voice over Wi-Fi is a constant challenge. It really is difficult to tune and deliver great voice performance over Wi-Fi. It needs a lot of TLC to get it to perform at an acceptable level. Roaming, so mobility challenges in hospitals where everything's in motion and in use while it's in motion. That's not a strong suit of Wi-Fi, and big challenge in hospitals in particular. Prioritizing traffic, and we'll get more into this, but some traffic on hospital Wi-Fi networks is just, it's actually scary how critical it is. Could be part of communication that is affecting patient care and has to work now. And how do we don't have good tools and methods to prioritize that traffic in Wi-Fi, over the typical background traffic that's already there. We'll talk more about that too. We saw in the pandemic how important it is for patients and visitors to have great Wi-Fi, and it's not just a nice to have, it's really a need to have. If you think about that COVID patient that's in isolation, can't see the family, and they're stuck for weeks on end, that's their lifeline. And it's important that it's that they have functioning Wi-Fi as well. The legacy Wi-Fi clients, healthcare is just one of those places where Wi-Fi clients live forever. They could be 10 years old, but from a clinical perspective, the equipment is, maybe it's $100,000 MRI machine or imaging, some kind of imaging equipment like that, and it's going to have a 15-year lifespan, and it's got the Wi-Fi it came with, and we have to keep making that work. And that's a big challenge, right? Because it kind of holds us back from taking advantage of some of the newer features in the newer generations of Wi-Fi. So one of the things I didn't say is I didn't say that Wi-Fi is too slow for hospitals. And just to kind of put a finer point on that, this is a graph of the average AP, layer 3 throughput in a hospital system that's a customer of ours over a week. So each AP, in terms of real traffic they're putting on the wire, is around 1 megabit per second, with some peaks and valleys, as the days come and go. Sometimes those averages, and that's the average, not the peak, but sometimes that average gets up towards 2 megabits per second. So when we think about, new generations of Wi-Fi unlocking speeds of 10 gigabits per second and 40 gigabits per second and so on, that's welcome, and it's not a bad thing. But is it actually helping solve a problem? In other words, the real traffic over the air tends not to be very high throughput traffic. And of course, the big change with a new band for access is capacity. More channels means more capacity. 5 gigahertz can support a huge amount of capacity compared to 2.4 gigahertz. We could never do Wi-Fi in stadiums if we didn't have access to that 5 gigahertz band because of the additional spectrum. And having 6 gigahertz, having all that spectrum, means we're gonna have even better performance in stadiums because of the capacity that unlocks. But do we need it in hospitals? And I would say, the way to unlock capacity in hospitals is more about having a great Wi-Fi design, having a careful Wi-Fi design where data rates are appropriately tuned, CCI is appropriately handled. We have a great channel reuse plan where AP transmit power is good. We don't have too many APs. That tends to be a bigger problem than having too few in hospitals. When we solve all those problems, there's more capacity available over the air than most hospitals need. So looking at the same hospital system in this graph, what we're seeing here is the channel utilization. So how busy is the channel on average that the APs are using? This is just 5 gigahertz too. And so the top of this graph is just over 4%, so we're somewhere between 2 and 4% on average out of 100%, of course, that the channel potential could be. We really don't want that to go much above 40% normally for Wi-Fi to remain healthy. But there's still a lot of capacity available in the 5 gigahertz band for hospitals. And 6 gigahertz is a big increase in capacity that's welcome, but it's probably not something that's going to really solve major issues for hospitals unless they wanted to start doing things like very, very high throughput applications over the Wi-Fi, like the radiology group might be doing for imaging, although those are still, in my mind, use cases better suited for wired Ethernet and maybe a multi-gig or 10 gig Ethernet uplink for those machines. But like I mentioned before, prioritizing access is a real issue with Wi-Fi in hospitals, because we don't have great tools to do that. We have an AP and all the clients connected operating on this one channel, And we've got this whole mix of classes of traffic that are all competing and contending to get through to the AP or get their traffic down from the AP. And so we have emergency communications, that code blue call to the doctor's voice over Wi-Fi handset. And she has to get that call. It just has to come through. But we also have a guest watching Netflix, and they're all kind of, using the same spectrum. And Wi-Fi doesn't have a good way of saying, this is going to have to stop so we can get this voice through. We've got QoS, we've got WMM QoS. Making that work end to end, and bi-directionally is a challenge, and it's still just probabilistic. It's still just going to say, well, your voice handset gets into the voice queue, and the contention window is going to be a little bit smaller. The arbitration time is a little bit smaller, but it's not guaranteed channel access. And I think, hospitals, that's something that's really desired for them. Yeah, and just another look at the breadth of devices inside and outside of the hospital that go into healthcare Wi-Fi and are all sharing the same spectrum and trying to get access. So, what can Wi-Fi 6E do specifically in healthcare that can be helpful? If the capacity issue is not actually a major issue, if the network is well designed, at least not today. That'll certainly change in the future. But if we set that aside, where can we help? Certainly, if you think about some of the challenges for hospitals I outlined earlier, I think one of the major ways it can help is that we can offload guest Wi-Fi into 6 gigahertz. In a lot of hospitals, guest Wi-Fi is the largest consumer of bandwidth, of network bandwidth, I should say, compared to anything else, because it's streaming video, because it's gaming, it's downloading iOS updates. Every hospital right now is dealing with that iOS 15.4 update getting pushed to those iPhones that happen to be on their guest Wi-Fi. And the reason guest offload is important is because those are the clients that get refreshed the fastest, and that's where you're going to see 6 gigahertz support right away. So your guests are already showing up with Samsung phones, Google Pixels, and so on, that have 6 gigahertz support, and you'd be able to offload them onto 6 gigahertz and keep that clinical healthcare traffic on 2.4 gigahertz, remove some of the congestion that they're dealing with to actually improve their performance in the legacy bands. So lower latency. We have fewer clients accessing the channels. We should have far less CCI if we've got a good design, because there's so many channels we can reuse. So we should have lower latency, and if we have the clients that can support it, then our real-time applications should do better in Wi-Fi 6E. Another thing we could do is we can say, right, this is a line in the sand in terms of our hospital devices. We can draw a line in the sand and say, we're building a new SSID here that's maybe just 5 and 6 gigahertz only. And we're going to turn on all those roaming amendments, all those amendments to 802.11 that help roaming, because that's so important to us. And maybe we couldn't use them before because all the legacy clients break when we turn that stuff on. So we could put in a new SSID, turn on 802.11R, K, V, W is required for Wi-Fi 6E. So is WPA3. So let's create a new greenfield SSID with all those great Wi-Fi features we haven't been able to take advantage of. Let's give it a cool name, right? Let's call it, we're at HIMSS, we'll call it HIMSS Guest Premier. That's the one you want to be on. and encourage clients, hey, if you see that SSID, get on that SSID. And then, we can have our old SSID be hymns, guests, slow. If that's all you can see, then that's all you can see. And that's what you'd have to access. So those, tri-band compatible clients are going to say, oh yeah, Premiere is what I want. I don't want to be on slow. And certainly partitioning SSIDs by band has been a pretty common design architecture. And I think we can extend that into 6 gigahertz as well. It also helps reinforce, as the Wi-Fi engineer, to say, well, yeah, we've got all these legacy devices. If you can connect to the Premiere SSID, you're going to have better performance. I'm telling you, that's where you're going to get great performance. If you guys, and that's the rest of the hospital, go out and buy devices that can only connect to that old legacy SSID, you're going to get Wi-Fi from 10 years ago. And that's a limitation of the client. And that, I think, separating SSIDs that way is a good way of helping to educate the rest of the organization about those differences. So this is an interesting thing, a kind of a new idea, and that is, if we have 59 channels, 20 megahertz channels, or if we have 29 40 megahertz channels, just reading from the chart, 80 megahertz channels, we still have 14 of those. That's going to be the default channel width, at least here in the US, I believe, most of the time. But if you have all this spectrum, why don't we just, again, because we don't need the capacity for anything, urgent at the moment, let's take a section of those channels and carve them off and say, right, we're only going to use these channels for our medical voice over Wi-Fi clients and our most important telemetry devices, maybe our WOWs as well, if they're doing really, if they're doing real-time VDI, for example. We could take that Uni 8 part of the band, the top part of the band, and carve that off for a clinical subband, and still have 12 channels, 20 megahertz channels that we could exclusively use for those users. Now they're not contending for channel access along with guest and kind of other traffic that's out there. So that's a really appealing idea. Now, I think there are probably some of you, going at the keyboard already about that would require to add a second layer of access points, right? Which is true. If we want to do that, we need a second layer of access points, of Wi-Fi 6E access points, to provide, 2 layers of 6 gigahertz coverage throughout the hospital. But given the importance of that traffic, it might be a good investment. Maybe in the future, there'll be dual 6 gigahertz APs where you could potentially do that in the single enclosure. That'll be interesting to see how that comes about, but it's an interesting idea for sure. So a little bit about just the state of Wi-Fi 6E. We've got a lot of clients. We've got the Intel AX210, that's the chipset there on the right, that Windows 10 and Windows 11 support. That's been out for 2 years now. And if your WOWs don't have that, it's a pretty easy upgrade to get that installed and get them Wi-Fi 6E support. There's a lot of smartphones out there now. These tend to be the kind of the flagship level phones so far. Samsung's S21 Ultra and S22 Ultra support Wi-Fi 6E. Google Pixel 6 and the 6 Pro support Wi-Fi 6E. rumors about the 6A coming out this year. Those would be those guest users that are ready to go to Wi-Fi 6E and 6 gigahertz that are in your networks already. And there's more, certainly more. Of course, the big question is, when does Apple start to support Wi-Fi 6E? I thought the iPhone 13 would be it. Unfortunately, it's not. You know, Apple does their own thing, and you know, hopefully the iPhone 14 will be the one to support Wi-Fi 6E. If it's not, they'll be over 2 years behind their competition. And you know, who knows if that'll sway Apple or not. But their clients are there, and there's a lot more coming. So a couple things though to keep in mind about deploying and operating a Wi-Fi 6E network. The APs cost more. There's 3 radios. There are, you know, if those are 4x4 radios, you've got 12 radio chains in every AP. And support all that, all 3 radios, and you know, all the traffic and clients connected, they need faster CPU and more memory, and so on. All that ends up, you know, and all 3 radios are 802.11ax support radios, so all that adds up to, you know, a costlier AP. And the biggest consideration outside of the AP is your switching, because these APs, to get the full feature set from them, all the enterprise APs that have been released, to my knowledge, require 802.3 BT PoE. That's 60 watts of PoE. And I think the Cisco APs could also use UPoE, which is sort of their pre-standard 60 watt PoE plus option. And you know, interesting question around if you need multi-gigabit Ethernet and base T uplinks for the APs. I think most of the APs from the enterprise vendors that have been released have N-base-T Ethernet uplink ports, so you could deploy that. You know, going back to the amount of traffic that's actually out there on the Wi-Fi network, you know, make your own decision about that. But if it's time for a switching refresh and the budget's there, it's something to consider. And of course, you know, not to rain on the parade, but there will be significant bugs, just like there are with every new Wi-Fi technology, and rolling out support for a new band with its own requirements, and it is going to be challenging. You know, we know from experience it takes AP vendors time after a product is released to really have code that's stable and ready for production hospital networks. So, you know, use caution and do a lot of testing and check with peers about, you know, how they've the testing they've done before you start to roll this stuff out. Oftentimes with new generations of APs, the first generation with that technology is rushed so that AP vendor can be number one, you know, the first one to release that new generation of Wi-Fi. And so they try to get a product out the door really quick. And then the next product they released with support is like the stable, this is what the engineering team really wanted to do if they were able to design the AP they really wanted to at the time. So keep that in mind too. Yeah, the second generation of APs will probably have a longer lifespan and might fix unforeseen issues in the first generation. So keep all those things in mind as well. All right, I think with that we can go to some Q&A.
Awesome. All right, this is for Alfonso. time to get down to business here. All right, so we've got quite a few questions in the Q&A panel. So Jim, pick a number between 1 and 7.
How about 4?
4. All right. I don't know how to say this name, so I'm going to call you Dee Dee. Dee Dee has a question. Has the client channel scanning, probing, and beacon been ratified for Wi-Fi 6E now? If so, how does it work?
Yeah, great question, Dee Dee. But yes, so the standard, like it often does, leaves a lot of, just gives you 3 or 4 different ways to accomplish the same thing, and that's true for AP discovery and 6 gigahertz as well. So there needed to be some time for the vendors to kind of come together and decide, okay, how are we really going to do this? Let's not all do our own thing. And it's the primary method, probably the only method that will be used in the enterprise, is out of band discovery. So clients will scan and probe in 5 gigahertz or 2.4 gigahertz too. And the responses they get, the beacons they hear, and the probe responses they get will have a reduced neighbor report information element that informs them about the AP's 6 gigahertz radio, what channel it's operating on, what's the channel width, what are the SSIDs? They may be different SSIDs from what it discovered in the legacy bands. And that's how it's going to work. And check out David Coleman's WLPC talk from this year, where he got into the details of that too.
Awesome. All right, check that one off. Let's see, 1 through 6, number 1 through 6.
How about 6?
6. What is the difference between Wi-Fi 6 and Wi-Fi 7?
Ooh, good question. So Wi-Fi 7 isn't really well defined yet, but it supports the 3 bands, just like Wi-Fi 6E does, 2.45 and 6 gigahertz. The kind of headline features are for Wi-Fi 7 are speeds and feeds things. So we upgrade from 1024 QAM to 4096 QAM, which you can just shorten to 4K QAM, which the SNR required for that is incredible. So limited utility in the enterprise. And then we also in Wi-Fi 7 go from a maximum of 160 megahertz wide channels, which we probably still aren't going to use in 6E, to 320 megahertz channel widths, which we definitely, in the enterprise, are not going to use. I assume. Maybe we will, depending on how you want to partition that band. But I don't think we're going to have enterprise users selecting those 320 megahertz channel widths. And then there's a whole host of other things that are actually really interesting that are on the table for Wi-Fi 7. Multi-link operation, coordinated OFDMA, coordinated spatial reuse, HARQ, H-A-R-Q. These are really cellular-like features that really could increase spectral efficiency substantially for Wi-Fi. But what is in or out of the standard I don't have visibility into that. Certainly the first Wi-Fi 7 stuff that comes out, which may be as early as next year, I expect just to support 4K QAM and 320 megahertz channel widths, and the vendor will slap Wi-Fi 7 on there, and maybe that'll help out gamers at home, but it won't be a big help for us in the enterprise. It'll be several years before those enterprise features and the standard are actually complete that will be able to take advantage of that.
Awesome. And the questions keep rolling. I'm going to let you pick some here.
Yeah, a couple questions about coverage in 6 gigahertz and how it compares to 2.4. Wes Purvis from Mist had a great WLPC talk on 6 gigahertz as well. So I'd refer you to that. Look on YouTube for that. In general, it's 6 gigahertz coverage is 2 to 5 dB below what you'd find in 5 gigahertz typically. And it really depends on what part of the band you're in. So if you're on the low end of 6 gigahertz, that's where you'll see about a 2 dB difference in signal strength. But the 6 gigahertz band is so massive that if you're all the way up in Uni 8, you'll see a significantly higher or larger difference in signal strength compared to 5 gigahertz. So for solid 6 gigahertz coverage, you might want to consider a redesign. If you're using 6 gigahertz just for here and there in those high capacity, very high density areas, you might not need that right away. It really depends on how you want to use it. So.
What do you think? One more?
Sure.
Let's see. Your choice.
How about a friend of 7 Signal, Ariane, has a question for us. So get my mouse over there. He says a lot of hospital devices, cows, scanners, etc., are not going to be replaced by Wi-Fi 6E devices soon. I find it hard to push a full 6E deployment if clients are not part of the replacement procedure. Plus the fact that it can only be indoor omnidirectional antennas, so outdoor high capacity is a challenge. What's your view on lifecycle replacement and stick to Wi-Fi 6 and not 6E? Yeah, I mean, that's kind of what we covered in most of the talk. I think particularly around cows, you know, if you were buying cows or wows with those Intel AX 210 chips for the last 2 years, they were on the market, then you're in a good position. You know, it's really a chicken and the egg. If we say, well, we're going to wait for clients, well, then the people making procurement decisions will say, well, why would I buy the more expensive client if we don't have the network yet? So it's I would say there isn't necessarily urgency in healthcare to deploy Wi-Fi 6E, but I would consider it, you know, as in your normal AP lifecycle, to be thinking about, you know, when are we planning to refresh our APs, and does it make sense? Is the budget there? Is it really going to help us based on some of the things I outlined to go with Wi-Fi 6E in our hospital when we're there? Good question, Ariane.
All right. And I know I said that was the last one, but I know there's some questions about timelines and when this is actually going to go into adoption with the chip shortage and maybe priorities. So any thoughts there?
Yes. So I would say from my perspective, there's no special restriction on 6 gigahertz chips compared to 2.4 and 5 gigahertz Wi-Fi chips. There's also been some very strong public comments made by Extreme Networks and Aruba Networks. I think that just was published yesterday on Aruba's blog saying 6 gigahertz is here and ready and shipping, and you know, it's we're doing just fine. So I don't think, and I think in some cases there's better availability for Wi-Fi 6E APs than Wi-Fi 6 APs because they just hit the market, and there isn't already a huge backlog of orders for some AP vendors like there are for those Wi-Fi 6 APs. But check with your AP vendor; they should be able to give you the down low on their own status.
Sweet. Well, I know there were some questions out there, but we're happy to discuss more offline. Hit us up on Twitter. I dropped all of our social media in there. We're active on there. So if you have questions, just tag us, bother Jim on Twitter. I'm sure he'll be happy to answer any of your other questions. But yeah, I think really, really great webinar today, Jim, and I know you're going to do it again later, and it's going to be just as great. But yeah, thank you so much, everyone, for joining us. We're going to go ahead in the pool. So again, we'll get this into your inbox soon. Next week, we are actually going to be joined by Brandon's joining us for 802.15.4. Coexisting with 802.15.4 is our next webinar. So we'll see you then at 11 o'clock a.m. Eastern Wednesday. So have a great rest of your week, and we'll see you later.
Thanks, everybody.
Thanks.